Hello, welcome back to SQL programming practical session. Today we'll be talking about the basics of structured query language. I'll give you some insights into the theoretical aspects when I start this class. Then on module 2 we'll see the basics of structured query language programming, which is um, basic query, alias, distinct, filtering rows, sorting rows, and limiting rows. I will be showing you basic statements or queries pertinent to all these topics. For ease of manipulation and working, I will be using an online platform, Live SQL, which is Oracle's cloud platform to practice with already built-in database schemas. So I'll be using a schema called HR. As you can see here, there are different schemas, but I will be using human resources schema. If you go to human resources schema, there are different database objects, including tables. For instance, if you see here, we do have countries, departments, employees, and some other tables like jobs, locations, regions, and similar such kind of tables are available. So I start working on this one, and then let us show you how you can query data from an existing database or an existing schema. So let me get you back to the outline. So we'll be talking about what SQL is. So let me start with that. So SQL, in extended form, is a structured query language. They call it intergalactic data speak because it's the most popular technology or script, or you can say interpreted programming language that helps you to speak with the data, usually the relational data or relational database in general. So when we say relational database, this simply means entities are defined uh, with their relationship, okay, with other entities, with their relation, based on their relation. So one entity can be defined as an entity that are in relation with another entity. So this is the basic or the fundamental concept in relational database management system. So relational database management system usually are expressed in terms of tables. There are actually different objects, database objects, but the most common ones, a common one is table. So a table is again a database object that has rows and columns. So if you see an Excel spreadsheet, you can consider it as a table. Okay, if you see anything that has columns and rows and that stores data in each of those cells, or that we can call it table. So the first thing, entities are defined with their relationship with the other entities, okay, and the most common database object we call under relational database management system, or while talking about structured query language, is table. So there are different environments for SQL. For instance, you can say Oracle. Oracle also has different versions or releases. For instance, Oracle 8i, 9i, 10G, 11G, 12C, 18C, 19C, 21C, and later 23C. So all these are in support of structured query language on their platform. So today we will be working on the online or the cloud version of Oracle database, Oracle database 19C. We'll be querying or we'll be learning how to query on existing schemas. These existing schemas, as I told you, for instance, we'll be using HR schema for now, is list of database objects which are owned by user HR, and their major purpose is to have a minimal resemblance to human resource schemas. Okay, human resource schemas. So in human resource, for instance, if you see carefully, we'll have departments, employees, okay, and departments may have some sort of locations. Some locations may have countries. Countries may belong to some regions. And if you get back to employees, employees may have jobs, and similar things are available under the human resource schema of an existing database. Now let's talk about the practical part of this structured query language. We'll start with the basic query. For each of these topics, I will be giving you syntax, and then I will be defining an application, and then I will be writing a script to address that application. So basically, we'll be talking about a query, the syntax of a basic query, alias, distinct, and then we'll talk about filtering rows, sorting rows, limiting rows. Okay, so this is a very short video, and you'll learn more from this. So let's talk about basic SQL query, structured query language based query. So let's start with syntax. Okay, so a basic query has the following syntax. Okay, select, it's a keyword that helps you to pull data from the database. So that's the first thing. So here we have to list column or columns. Okay, select column or columns, because we say table is a combination of rows and columns. So here you list column or columns. Okay, then you have to say from, because you select these columns from some table. So here you have to write table name. Okay, so this is the basic query syntax. Let me give you one application, for instance. One application. List all employees from human resource. Okay, schema. So there are two things pertinent to this query. For instance, if you want to select all columns, okay, you can use asterisks. So that's one tip for you. So then the query asks us to list all employees from human resources schema. So that could be done like this: select all from, since the table doesn't belong to us, it belongs to HR schema, we have to qualify it with the schema name. So we have to say HR dot employees. Okay. So in order to run this query on SQL worksheet of Live SQL, you have to select it and click on Run on the top right corner. So as you can see, this query fetches all data, all columns and their corresponding rows as a result set. So as you can see here, this table has columns, or we call them fields or attributes, like employee ID, first name, last name, email, phone number, hire date, job ID, salary, commission PCT, which is a commission percent, manager ID, a person managing that employee, and department ID, a person where the person belongs to. So this is the basic one. But to extend this syntax for basic query specific to this application, we can also write like this, because we said column or column. So if the query were like this, list first name of all employees from human resource schema, then we could write like this: select first name. As you can see here from the result set, first name is written like this, so first underscore name from, okay, the table is hr.employees. Then I will run it. So this one will extract only first name specific data for the whole employees. Okay, so this is a very important concept. Very important concept. So if you want to list more columns, for instance, not all columns, but more columns, you can say like this: select first name. If you want to list all name, like full name, sorry, then you can say last name. So it should be comma delimited to list more than one column in the result set. So from hr.employees. Okay. Then when I write this one, you will see this. The other important concept here is that alias. So if you want to give additional name for your columns or a combination of columns, you will use alias. Alias is like a made-up name for your columns. So there are two purposes actually for alias, to use alias. The first one is security purpose. The second one is presentability. Okay. For instance, a column with weird name might not have to be displayed for the end user. So presentability, easy names could be used as a replacement for the existing database specific column name. But from the security side, for people who SQL inject or for people who SQL inject or do some data breach, I would say, letting them know the name of your column is for them one step ahead to breaching your database. So for that purpose, you have to mask, you have to mask the real name of columns or even tables sometimes. So on the result set, you shouldn't be displaying your real column names like this. Okay. So presentability is the second one. The first one is security. So for both, this alias is very important. So how do we write alias? Let me show you the syntax. The syntax for alias is like select column name. Okay. Then here you can write, for instance, like this, alias name. For another column, for instance. Okay. For another column name, you can simply write like this, new name, okay, from table name. So let me give you one application like this. So let's say there is a report or application request that says report full name, okay, of all employees. Full name of all employees. So this full name basically means, from the data structure we have, it means first name, right? Then space, last name. How do we do that? That's mainly based on alias, but in order to concatenate these two attribute values, we may use one of this. The first one we could use is this one. This means concatenate, okay? The second we could use is a single row function, which is a character function. We call it concat. So I will not be discussing about concat now, even though it's very simple. I will be using the low-level keyword for concatenation. So how can I do this? So I have to concatenate first name with some sort of space, right? First, then I have to sort the result of this one with last name. So to do that, I will do select, okay, let me cancel the comment, first name concatenated with some open space, right? Then this should also be concatenated with last name. Now alias comes. What shall I call this name? I can call it full name, right? Then from the usual one, HR dot employees. Okay, so if you display this one, you won't see first name and last name. You only see full name as the name of the column. You see? This is very important one for reporting. So this is a basic query. By the way, if you don't know details about the structure of your table, okay, then you could use this command, which is desc or describe table name, to see the structure of the table, okay, the definition of the table. For instance, if you want to check the structure of the table employees of HR schema, you may say desc HR dot employees, and then you'll see, when you run this one, you will see the detailed structure of this table employees. You see, the list of columns are here, the constraints, especially null constraint, whether it is defined or not. For a column which is not null, you cannot put a null value or empty value. Then the domain or data type is also listed here. Okay, listed here. Okay, good. Then the other important concept you need to know while talking about or while dealing with basic structured query language is distinct. Distinct means unique. Okay, so it's a way to fetch unique values from a table or tables. Okay, we call it distinct. So how do we do that? For instance, we can say list all employees ID, okay, which is not redundant. For that, for instance, I can simply write, first let me show you the syntax. Okay, syntax. The syntax can be written as select column distinct, then from, okay, table name. That's simple one. So we can say select, okay, for the ID, which is employee ID from before that we have to use distinct. I guess I think this is not the right one. Distinct. Yeah, distinct is like this. So distinct from. Sorry, I have to put it here, right? Distinct. Select distinct employee ID from HR dot employees. So this would fetch distinct list of employee IDs. So distinct list of employee IDs will be fetched because of this distinct keyword. So these are unique by default. Since employee ID is a primary key or a unique key of the table HR.employees, by default there will not be any redundant employee ID. But if there is any redundant data on that table, then this query will make sure that data is fetched uniquely. So for instance, if I change this one for department ID, okay, department ID, like multiple employees may have one department ID. So department ID is more likely to be repeated. So what you'll get here is a unique list of department IDs. Okay, there will not be redundancy. Okay, so for this, for instance, given employees table only, one may ask list departments where employees work. So from the employees table, if you want to fetch list of departments, so redundancy is not required. So you can simply list departments by using distinct department ID. Okay, so like this. Good. So this is a very basic SQL query. Now let's see how we can filter uh, while fetching from tables or database. Filtering is selecting based on condition, okay? Based on condition. So the syntax for this one is select, okay, column or columns from table name where clause is here for the selection process, where column name operator, okay, and value. Usually the operator, there are different types of operators. Let me tell you about them. For instance, arithmetic operator is there, which are plus, minus, division, multiplication, modulo, different operators are there. Relational operators. These relational operators are also called comparison operators. So these are greater than, less than, greater than or equal to, okay, less than or equal to, not equal to. In other words, we can also say not equal to. So there are different operators again. Logical operator is there. Logical operators are operators that provides true or false. So these are and or not. These are logical operators. So for filtering purpose, for selecting specific data from the whole data, you might have to use relational operators and logical operators, or any of this. So relational operators are must usually. Logical operators are also there. Okay. So let me give you another syntax. Okay. So you'll say select column or columns from table name. Okay. From table name where column name is there. Operator is relational operator, right? Relational operator value. It could be like where salary greater than 10,000. Okay. You can also use logical operator here. You can say and another. So and is like logical operator. So let me say logical operator. Okay. Logical operator and another relational operator after that, which is, for instance, column name relational operator value, then semicolon. So let me give you application now to practice with this syntax. The application is, let's say, a boss, okay, wants to know details of employees whose salary is above 5,000. So for this, our condition mainly bases on the value of salary. So according to the syntax, select details. So all information is a good example for details from hr.employees where, okay, salary, this is the relational one, right? This is condition one. Salary above is greater than, right? Greater than 5,000. So this query will fetch details of employees whose salary is above 5,000. So if you see the salary column of the resulting set, you see 24,000, 17,000, 19,000, 90,000, such something like that. So you cannot find salary like 5,000 or below in this result set. This is due to the fact that we used relational operator, which is salary greater than 5,000. But what if the person adds something more to this request? What if he says, for instance, what if he says, and who works for department, say 100? These are two conditions, right? First, his salary or her salary should be above 5,000, and specifically they should be working for department 100. So for that, department ID is the target column. Let me copy paste this one for is. Then here, since he said and, we will use a logical operator and. Then we say department ID is equal to 100. Then if you run this one, then you will get list of employees who works for department 100, you see, the department column, and whose salary is above 5,000. Above 5,000. So this is basic example of filtering rows from a given table. So this is a select statement with filter or with condition. So we just advanced it a little bit more. So we can have different examples, but this is, I would say, sufficient for what we are trying to achieve. The other important topic here we'll be discussing is sorting. Then you might be filtering or you might not be filtering your target table, but you may have to order it, right? You may have to order it for ease of understanding and readability. So for that, how can we do that? We use sorting clauses of structured query language. How do we sort? So sorting basically is what? Ordering. So how do you sort? Let me show you the syntax, okay? We do this. Select column or columns from employees. Sorry, I shouldn't be mentioning the specific name. So from table name. So you may use condition like where, or you may also eliminate it from this syntax. So to make this easy, I will use the sorting syntax. So order by is the clause for sorting, and here you will name column or columns. So this is a basic one. Okay. Then now I'll give you application so that you use this syntax. The application is say report the name of employees, which is first name plus last name, by ordering it from like small, I would say, like small to big, which is ascending, right? Ascending order. By ordering it is like first name. Let it be first name. By the way, for the syntax, one thing I forgot is we need to specify whether it is ascending or descending order. Okay, so the default is ascending. So if you want to order it as in ascending order, you can avoid this one. You may not. You may say nothing here, but if you have to order it in descending order, descending means from larger value to smaller value, you may have to say descending. Okay, so here for the character, ascending and descending is calculated as per their equivalent ASCII value, cumulative ASCII value. Read about ASCII value, ASCII. But for numbers, it directly uses the numbers values or their equivalent binary value in general. So how do we do this? So we say select first name, or you can also say all, by the way, because we are not actually it says report the name of employees. So name means first name and last name, right? Last name. Okay. Then from hr.employees, order by, right? Order by first name. I have been asked to order it in ascending order. I can avoid ASC. It's the default is ascending. So if you see this, the result is like A first, then B, C, D, like this, E, G. So this is ascending order. If I change it like this, descending order, okay, you will see the last name available. So W is the last one, V, T, S, R, something like that one, okay. So this is how you order your table. But one more thing, you need to order sometimes with more than one column, because let me show you one example here. For instance, if you see here, let's see, let me rerun this one in ascending order, and let me show you one example. For instance, name Stephen is repeated somewhere. I don't know why it's not showing me. Let me list first. Let me list the specific name I'm trying to show you. First name, like S. I'll talk about this one later, but S. And let me order this one. So for this, for instance, we do have Samuel, Sarah, Shelly, Seagal, Stephen. Okay. So sometimes you might see the table ordered well by first name, but not well by last name. So for instance, for redundant first names, it might not sort it well. Here, for instance, you might see Markle first while sorting in ascending order, and King last. So if you want to order with more than one column, you could use the same thing but with a little bit different syntax. So let me copy paste the previous syntax here, and here, and then select column from table name, order by column, ascending or descending, comma, again the same thing will be repeated. Okay, column. So let me remove this one, again in ascending or descending order. Okay, so let me again reorganize the previous application so that we will use this new syntax. Report the name of employees by ordering first name. Let me make it let me make it technical. Okay, first name in ascending and last name in descending. So this is pretty simple application, right? So we can write select first name and last name from hr.employees. Okay, we don't need where condition now. Order by, because there is no way to filter, or there is no ask to filter this. So order by first name, the first column is first name in ascending order, or I can also remove it like this. Okay, but for descending I have to explicitly mention, so last name descending order. So if you run this one, employees with the same first name will be sorted by their last name. Okay, so if you want to order using multiple, or sort using multiple columns, you will use this one. Okay, you will use this one. So for instance, if you see Alexander, there are two Alexanders, but their last name is ordered in descending order. By the way, if I order the last name in ascending order, you will see a different story here, because Alexander Hunold will be the first one. Let me show you again. See, Alexander Hunold first, then Alexander Koch next. So this is how you basically order filtered or unfiltered result sets. Okay. The last topic I will be showing you today is limiting rows. You may want to, for instance, pick the first 5 rows of your result set, or the first 10% of your result set, either with ties or not. So when we say with ties, for instance, if you are picking the first 5 rows of your table, then if the fifth row has some sort of tie or relation with the sixth row, you may have to fetch it, right? So for that, you may limit rows with ties or without ties. Okay, so the syntax for limiting rows is the same thing, like select column, okay, or columns from table name. You may use where, okay, it's possible, but this is basically optional. Okay, this is optional. Again, another optional thing, order by is, okay, so order by column name. This is also optional. Then fetch first is a keyword. Fetch first. Let me use this for number. The first one is rows only. This is the first syntax. Let me copy this one and show you the second variety of this syntax. I think I have to put it down like this. This is the first one. Let me call it syntax 1. Okay. The second one is syntax 2. So the same query I will be using. Okay. But the difference is here, for instance, we said fetch first this number of rows only. Okay. The second one is fetch first this percent rows only. It's in percent. Okay. This is syntax 2. And again, let me copy paste this one. Okay. Syntax 3. Syntax 3. This is percent rows only, right? For percent rows with ties. If you want ties, you will use this one. The first syntax is this one, and it's not percent, but fetch first this number of rows with ties. So there is a big difference, right? So let me show you for the very first query we wrote, for instance. For the first one we wrote, for instance, let me copy paste it here. Then select all from hr.employees, but I don't need all those 100 and some data, but I want to fetch first 5 rows only. So you will see only 5 rows listed on the result set. See, 1, 2, 3, see, from 0 up to 4, which is 5 rows. Again, let me copy this one to the second one, which is fetch first dash percent of rows. So let me take 5% of rows only. Okay, so I will add percent only here. So when I run this one, 5% of the total rows in the table is like 6, I guess. So 6 rows will be fetched, as you can see here. But if you want to fetch rows with ties, you can add, you can delete with only, and you can add with ties. So if there is any tie between the 6th row and the 7th row according to the previous query, then it will be fetched. You see, it will be fetched. But for now, since there is no match tie, it's not fetched. But you can search for such scenarios. Okay. The last one is fetch first 5 rows with ties. This is without percent, but with ties. Okay. So if you see this one, it fetched only 5 rows. But if there were a tie between 104 row and another row, which is the next row, maybe 105, it will fetch it along with the 104. So far we have been talking about what is structured query language. We said it's called intergalactic data spec, right? And we also talked about basic query, what basic query looks like. We talked about filtering. We talked about limiting. We talked about sorting. This is enough for today. Maybe in the next consecutive and subsequent classes, I will be talking about more practical aspects of structured query language and more complex aspects of it. But for today, I would say ciao.